Okay, first I have to introduce everyone and welcome to for today's session. So now I would like to introduce today's speaker for this webinar, Ms. Is working in the TCS as a system engineer, and she have as a various certification, industrial certification she got in their graduation. She have AWS cloud certification and other five industrial certification. So she is moreover more cloud computing grips she have. So now I hand over to ma'am, Jill ma'am. So say they are start their webinar today. Okay.
Hello. Thank you, Uday sir, for introducing me. I am going to start. Is it visible?
Yes, ma'am. It's visible. Ma'am.
Okay. So today's our webinar topic is all about cloud computing with AWS. So before starting this, as Uday sir already introduced me, I have completed my education from in a Bachelor of Technology from Chartered University, and currently I am working as a system engineer at Tata Consultancy Services. Till now, I have done 5 industry recognized certification, and those are 3 of them from AWS certification. One is the Microsoft Azure certified, and the last one is the Oracle certified certification. I have till now I have migrated more than 20 websites to AWS and designed more than 13 architecture with AWS best practices. So today's our webinar content is all about introduction about cloud computing, benefits of cloud computing, what is AWS, then we will see overview of AWS core services and its category with AWS best practices, and at the last AWS certification pathway and preparation. As AWS certification is very helpful at the student level. If we get the AWS or any industry recognized certification, then it is very easy for us to get the job at when we are at the fourth year and after completing our graduation as well, because nowadays certifications have a very huge demand in industry as well. And if you have this any in any technology, if you have this industry recognized certification and any specialization, then you get your desired domain as well, right? So before moving to the AWS, first we will see what is cloud computing, why it is important, and nowadays why this technology is booming in industry, and then we move to the AWS. So what is cloud computing? So cloud computing is not at all a new technology. It is the mixture of all existing 4 technologies which are there before cloud computing in the market. And those 4 technologies are utility computing, cluster computing, grid computing, and virtualization. We will see what is utility computing, cluster computing, grid computing, and virtualization before defining cloud computing. But cloud computing is mixture of all these 4 technology and which is known as cloud computing. So first we will see what is utility computing. So utility computing is nothing but it is a packaging of computing resources like compute, storage, network as a metered service similar to a traditional public utility like water, gas, electricity, and telecommunication. What does it mean? Like if we are living in a house, we have to pay gas bill, we have to pay electricity bill, right? So whenever we pay the bills, whatever we have consumed, it's the same kind of concept over cloud computing as well. Like you have to only pay whatever you are using. The concept of pay as you go in a cloud computing, which comes from utility computing. The next one is the cluster computing. Cluster computing is what? It is a group of server and other resources. Other resources in terms of server means it's a computation. Other resources means storage and network that act like a single system to enable high availability. Means if you have in a cluster computing, if we have a same configuration, same operating system in the same network, then we can connect all those computers or all those servers and work on that. So we get higher power or higher, or we can say higher CPU. If we have a two machines with the same configuration, and on both the machine we have a 8 GB of RAM, and we can say 1 TB of hard disk, and we want to run a program, or we can say some application that need more than 8 GB of RAM. It is not required at all, but at that time we have to combine these two computers, and they both work as a single system. It's called cluster computing. uh, the same concept in a grid, but in a grid the complete opposite than cluster. In a cluster computing we require same network, same hardware, same operating system to create a single system. But on the other side, in a grid computing, it is a distributed computing model, which is applying the resources of many computers in a network in a single problem at the same time. Means in a grid computing, if we don't have a machine on a same network, then also they can work as a single system using grid computing. And we can say that many we have some big data analysis, or we have to run some find a prime number of 1 to 1 lakhs. At that time what we can do, we can divide the problems in a many small parts and run it on all the systems, and then we can merge the output on the master node. That's the concept of grid computing. And the last one is the virtualization. Virtualization is the most important, and it is the most important for cloud computing, because in a cloud computing, all the resources, all computation, storage, network, all that, we don't have anything as a physical. We have all this as a virtual mode, right? So virtualization means to create a virtual version of a device or a resources, such as a server, storage device, network, or even an operating system, where the framework divides the resources into one or more execution environment. If you have an idea about VirtualBox or VMware, then on the same computer we can run two operating system at the same time using VirtualBox, right? Am I getting? Are you getting my point? Okay. So virtualization means on the same hardware we partition it and run the different kind of OS on the same hardware at the same time. It's called virtualization. So from all these four technology, we have the next one. We have a new technology which is called cloud computing. So cloud computing is on-demand delivery of compute, power, database, storage, application, and other IT resources via the internet with a pay-as-you-go pricing. What does it mean? It means on demand. It means whenever you want, wherever you want, you can use those resources. Like in terms of resources, I mean compute, database, storage, or network via the internet. So internet is must to use the cloud computing. And with pay-as-you-go pricing, pay-as-you-go pricing, it means you have to only pay for those resources which you are using. Means you don't have to pay all. If you are using the server on a cloud for 2 hours, then you have to pay for only those 2 hours only. You don't have to pay much than that, right? So it is a very easy and a very handy to useful, because sometimes in an organization, if you want some hardware or server which require more RAM or more storage, at that time we don't have to purchase all things as a manually, right? To run a single task, we don't have to purchase, or it is not feasible to purchase all the things, because it requires a lot of time for maintaining all that. So at that time, cloud computing is a much easier way. You can get the software, you can get all the resources wherever you want and whenever you want, and you can start using it very easily, and you don't have to pay for them. If we let's take an example. If we want to run some machine learning algorithm and that want a GPU, or if we purchase the GPU system, then it may cost us more than 1 lakh rupees. And after purchasing that, we have to maintain it, and maintenance cost is also very high for that. But on the other side, if you want to run machine learning program on the cloud, then you don't have to don't have to do anything. You just have to take one EC2 instance with GPU configuration and just launch it, use it. After if you are your program is running for 2 hours or 3 hours. Then after completing 2 3 hours, you can just terminate the instance, release the resources. You only pay for those 2 3 hours, and your work is done. Right? It is very easy and very handy to useful. So nowadays it is very useful, very much useful in a industry as well, because all the most of the charges in a industry we have to pay for the maintaining the server and resources, because it's a very crucial thing at the industry and organization level to maintain their servers and software. And because of the cloud computing, all these things is reduced now. We don't have to manage and maintain anything. All these things will be maintained by third party. Like if you are using AWS cloud, then all these things will be managed by Amazon. If you are using Azure, then all these things will be managed by Microsoft. If you are using some other service, then that company will manage all those resources and all that, right? So what is the difference between traditional computing and cloud computing? Okay, so the main difference between traditional computing and cloud computing is that in a traditional computing, everything whatever we have as an hardware, right? Nowadays, if we now if we have an organization and we want a server, and if we are not using cloud, then we have to take a lot of purchase a lot of servers and racks, and create the data centers like in this picture. So we have to maintain all these things. So we can say whatever our infrastructure is on premises, we have to we have it as an hardware. But on the cloud computing, all the infrastructure is as an software. Means all this in a virtual mode. Nothing is as a physical, right? In a cloud computing, everything is working as a software in a virtual mode. You have to use those servers, you use those services from the internet only. You don't have anything at your physical location, right? So now the question arises, everything whatever on the on-premises server, the same thing shall we get on a cloud computing? Yes. Here you can see the comparison. On the left hand side, there is a traditional on-premises IT specification and IT services, whatever we have on-premises. The same thing, here I have taken the example of AWS, whatever the same services available on AWS in all the main domains, like in a security, in a networking, in a computing, and in storage and database. So for example, in a security, on-premises data center, we put firewall, we have an access control list, we define the administrator who can access, how many users can access, and all that kind of rules and regulations at our data center, right? The same thing we can create on AWS using the services called security group, network access control list, and identity and access management. Security group is working same like a on firewall at AWS level. And network access control list is also, but those two things are different because security group is working at a server level while network access control list work at a subnet level. Third one is the IAM. IAM, the full form of IAM is identity and access management. In that, we can create user, we can create group, and we can create the policy, assign them policy, means permission, which user can access which kind of resources, what are the permission they are allowed or not. Means like if our organization we have a developer, we have a finance team, we have a HR team, we have a system administrator team, right? So they have they all not require all kind of resources. Then we can create group of them and assign permission according to that. Like developer wants to use servers, then we can assign them permission of EC2 server and S3 and all that. If administrator want to troubleshoot and monitoring all that thing, then the monitoring services like CloudWatch, CloudTrail, config, then we can assign permission to AWS administrator according to that. Okay. On the networking side, we have an on-premises router, then we have a network pipeline, and we have a switch. On the same thing on AWS, we have a VPC. VPC means virtual private cloud. You can create your private cloud on a AWS as well. And the second is the network pipeline and router means elastic load balancing. It is useful to distribute the load between server. You can it is very easy to distribute the load on a server using Elastic Beanstalk on a cloud, but it is very difficult at the on-premises level. But using ELB, means Elastic Load Balancing Service, and VPC, you can create your private cloud and you can put all your security or whatever things that like you want want some more security, you want to allow only only authorized person to access your network or server, then you can create your private cloud on AWS and put all the security measures over there as well. On the compute, in a compute department we have on-premises server. Same thing for a compute on AWS, we have Amazon EC2 instance. These instances are working on AMI. AMI means Amazon Machine Image. It is the same like ISO system. I mean, we can use ISO file to load the operating system, right, on our machine, on our physical machine. The same thing on AWS, they are using machine image. It is not, it is the same thing. It is the one template on which operating system is loaded, and you can also uh, create your own AMI as per your software and as per your configuration. Like you want, whenever I create a server on AWS, I want this much of systems or this much of software installed by default on my machine. Then you can create your own AMI and you can launch the instances from that AMI. So whenever you are launching an instance, all the softwares and all the dependencies will be there directly on your machine. So don't have to install all those things every time whenever you create your instance, right? Okay. In the storage and database, we have a on premises we have a three kind of DAS. I mean, it is a kind of a block storage, means a disk area storage. The same thing over AWS is called Elastic Block Storage. It's called EBS. It is nothing but the hard disk of our physical machine. On premises, we have HDD and SSD. SSD have a great performance, and HDD have a very less performance. But on the other side, cost for SSD is a very high. But on AWS, every time whenever you launch any EC2 server, by default there is a SSD volume attached to that. They never use HDD concept. They have HDD concept over there as well, but they never recommend to use it as a root volume. Means when where your operating system is load, every time they use SSD only, so you get great performance over there. The next is the storage area network. Means you can share the storage between multiple servers. It's called storage area network. We have it on premises. The same thing over AWS is called elastic file system. The same concept, you can share your file between multiple EC2 instance on a using same storage is called elastic file system. So whatever file you have put, you have to mount it on all the EC2 instance, and whatever file you put it on a EFS, it is visible on all the instances which are attached to that EFS, right? Then the next one is the NAS. NAS means network area storage. It is the same like file level storage. So for that, there is an Amazon S3. It is a very great service of AWS. It is a service which we can say firstly launched by AWS, and it is the first customer of Amazon S3 is a Dropbox. The Amazon S3 is a service where you can store all your files, all your videos or images or whatever you want. Like only two things, means Amazon S3 is the object level storage. So at in Amazon S3 you cannot load database or you cannot load operating system using Amazon S3. So it is called object level storage. For installing operating system, you have to compulsory use EBS volume. And for database, we have a different service which is called Amazon RDS. It's called Amazon Relational Database Service. So, so in that you can uh, launch your MySQL database or PostgreSQL or Aurora. Aurora is a proprietary database which is completely managed by AWS. And another one is the Oracle and Microsoft SQL Server. You can load all these file database using Amazon RDS service as well. There are lots of other service for database as well, like DynamoDB, like Neptune. If you have a graph database, then you can use on AWS Neptune service. If you have a NoSQL database, then you can use uh, DynamoDB service. They all services are managed by AWS. So it is provide very great performance, highly scalable and highly reliable. All these services are very highly scalable, reliable, and you can get access within a minute or within a click, right? Okay. So before moving to AWS, first we will see what are the cloud services model. There are mainly three models: software as a service, platform as a service, and infrastructure as a service. So, uh, whatever cloud provider, if someone provide infrastructure as a service, by default they will provide platform as a service and software as a service as well, right? So infrastructure as a service means what? They can provide you an infrastructure like compute resources, storage resources, like and the example of that are Amazon, Windows means Microsoft Azure, FlexiScale, GoGrid, all that are cloud provider which provide you infrastructure as a service. And the same thing, like I have, as I have mentioned, the same thing like Amazon provide infrastructure as a service. Then there is a service over there which provide you platform as a service, and there are some services which provide you software as a service, right? Okay. So in the platform as a service means we can say all the platform and all things are ready. You just have to deploy your code, the platform and the complete platform, underlying platform, operating system and database will be managed by the cloud provider. It's called platform as a service. Means whenever you don't want to manage any kind of infrastructure, you don't want to manage operating system, patching the operating system, or we can say you don't want to install the dependencies or don't want to manage the database, at that time you can use platform as a service. In that you just upload your code in any of the framework like Java, .NET, Python. It depends what service you are using. They may differ as per the requirement. Like in AWS there is one service called Elastic Beanstalk. On Elastic Beanstalk is provide platform as a service. You just have to deploy, upload your code, and everything else will be managed by AWS. On a back end, it will create EC2 instance for you. It will create a load balancer for you. It is automatically create database for you and connect all that. And your website will be running within a 10 to 15 minutes. So, and it is very easy for maintaining the version. If you want to change your website, then just simply change it on a local machine and then upload the code on Elastic Beanstalk again, and your new version will be reflected, right? Okay. The next one is the software as a service. It's a software as a service is nothing but ready-made software is available, and you just directly use those, like Google Docs and Facebook. It's called software as a service. Software as a service means already softwares are available over the internet. You directly use it on your phone or on your machine, right? It's mostly business applications and multimedia applications are providing software as a service, right? Okay, the next one is the cloud deployment model. So there are mainly three cloud deployment model, and those are public cloud, hybrid cloud, and private cloud, right? So the public cloud means, as the name suggests, public means it's available for all in general public, right? So anyone can use public cloud at anywhere. It is highly available, highly reliable, and highly scalable as well. Example of the public cloud is that Amazon, Microsoft, Google, IBM, Oracle, and many. All those organizations provide public cloud, and you can use it from anywhere, right? Uh, the advantage, as I mentioned, it is highly scalable, flexible, and reliable. But on the other side, disadvantage of public cloud is that it is not more secure. Means you have a sensitive application or you have some sensitive data that may not to be stolen or may not available over to the public. Then you can, at that time you cannot use public cloud. Means security is less at the public cloud, right? The next one is the hybrid cloud. Hybrid cloud means as the hybrid cloud means the connection of hybrid cloud is a combination of private cloud and on-premises cloud, right? You want something on a AWS, or we can say any of the public cloud, and some of them which are already exist on your on-premises, and you want to connect both of that your on-premises data center with any of the public cloud. At that time, you can create a hybrid cloud. You can use hybrid cloud concept. Uh, Hybrid cloud is a very great, and most of the organizations are using this because they put their web servers and all this on a public cloud, because web servers and all means websites and applications are available for a general public, right? So they put those kind of softwares on a public cloud, so they don't have to manage those things. And the database server and their organizational data and all that, wherever they store, they put this all this file on their on-premises data center and connect both of them. So whenever we require something from on-premises, from cloud to on-premises, at that time we can easily access it. But the advantage of hybrid cloud is that it is uh, very feasible, reliable, and scalable as well. But on the other side, disadvantage of hybrid cloud is that maintenance is more. You have to maintain more things. Means you have to check for the connectivity between the cloud, public cloud, and your on-premises data center. So it requires high maintenance and huge work from your side. The third one is the private cloud. Private cloud is the same as the on-premises data center, but now it is also available on a public cloud as well. So as I mentioned on a earlier slide, that there is one service called VPC at AWS, on which you can create your virtual private cloud, right? So the same thing on a on a public cloud, you can create your private cloud as well, and you can, or if you have your on-premises organization data center, it is same like a private cloud. The concept, the advantages of private cloud is it is a more secure, more reliable, and all that. But the disadvantage of that is it cost you more. Means when you purchase all things on premises, then you have to pay all the bills at upfront, and you have to manage, and maintenance cost is very high. Cooling and all that, server cooling cost and all that are very high. So private cloud. So all this model have their advantage and disadvantage. So nowadays organization using most of hybrid cloud because they take both of the advantages as well, right? Okay. So the next thing is advantages of cloud computing. First and foremost advantage is stop guessing about capacity. Means uh, you can scale out and scale in resources. I mean, you can add as many server you want and decrease as many server as you want. Like uh, uh, if you have a website which is selling anything, and you know that on the like if we have an e-commerce website and we have a sale on a next week, then we know that on the sale days we on our website very huge traffic. So on those days we can set the auto scaling. Like auto scaling, it means you can set a policy on your server, if the server CPU utilization goes beyond the 70%, then automatically it will launch a new server which is ready to serve your traffic. So your application will never go down, right? So stop guessing about capacity. Means on a cloud, infinite resources are available, so you can use resources wherever you want. The next advantage is that stop spending money on running and maintaining data centers. So uh, as I mentioned, using cloud computing, it will reduce your cost on a data center. Like you have to purchase the server and you have to maintain that. You have to stop spending on that using cloud computing, right? So it will reduce your huge cost for maintaining data centers and maintaining and purchasing the server, right? The next one is the go global in a minute. The third one is the go global in a minute. So the go global in a minute means when you have your application and you want to available it over the globe within a minute, then cloud computing is the most preferable because you can use this. You can use any of the service which is available over a public cloud, and you can deploy your website or application, and it will be available within a minute around the world as well. So when you want, if you are launching your website on on-premises data center, then first you have to buy all that, then connectivity, does the connectivity, then maintain that, and then you have to uh, then you deploy your websites in that, right? So uh, using cloud computing, you can your website or application will be available within a minute, or within, we can say, within a few clicks of computer, right? The next one is the increased speed and agility. Agility in terms of you can change it in a frequent manner, and you can do it in a very fast manner. Means like right now, today at 12 a.m. if I launch, if I deploy any software or any we can say website on a cloud, and after 10 or 12 hours I want something to change, then you can change it on a local machine and just push it, and it is available to the world within a minute, right? It increases your speed and agility. This is the most reason why nowadays most of the companies are moving to the cloud, because it gives you a huge speed and agility. The next is the benefit from massive economies of scale. That means it's a kind of concept like wholesale. Means the more you use, the huge discount you get. It is the same concept like that. Like right now, most of the organizations have a fixed project, fixed length project. Like we know that our project or our server will be running for 1 year or 3 years. At that time, you can purchase it for, if you purchase the server for 3 years using AWS Reserved Instance Service, then you get the 50 to 70% discount on that. It is a kind of concept over all the cloud providers, right? So it's called like if you want to use more, then you get huge discount. And the next is trade capital expense for variable expense. Capital expense means stop spending on data center and servers. Instead of that, using cloud computing. That means variable expense. Like right, when we are creating on-premises data center, we don't know how much traffic on our website will be there. So we cannot guess anything on premises, right? Uh, at the same time, on a cloud, if we don't know how much traffic on our website, then we just simply start with one server. If the traffic goes high and high every day, then just we have to increase the server, and we can also do it in automation using auto scaling and ELD service, right? So you don't have to manage and maintain all things. So trade capital expense for variable expense is that. Okay. So this is all about cloud computing, benefits of cloud computing, why it is useful, and nowadays why it is used in a market very well. Now moving to the Amazon Web Services. AWS is a most used, or we can say in a cloud computing, 95% of resources are available nowadays to AWS, and it is a more it has more than 100 plus services on a cloud, and in a cloud computing it is at the first rank, we can say that, right? So what before moving to the Amazon Web Services, first we will know what is web service and what is the meaning of web service mean. So a web service is any piece of software that makes itself available over the internet and uses a standardized format such as XML or JSON for a request and response for an of an application programming interface. I mean, it's abbreviation at API interaction, right? So web service means nothing but we can say it's one kind of communication. You can request using XML or JSON to any of the server, and you will get a response from the internet, right? It's called a web service. You have over the it is doing over the internet, that's why it is called web services. And you for a request you can use XML or JSON, and you will get response from an API, right? Okay, so what is an Amazon web service? Amazon web service, AWS, is a secure cloud platform that offer a broad set of global cloud-based products. AWS provides you with on-demand access to compute, storage, network, database, and other IT resources and management too. It also offers the flexibility and you only have to pay for the individual service you need for as long as you use them. It is the same like right now if I am using as a for compute I am using EC2 server. For storage I am using S3 or for database I am using RDS. Then I have to only pay for compute resources. Like if I run EC2 server for 3 hours, then I have to pay for those 3 hours only. I run my database for 5 hours, then I would have to pay for the database only for of that 5 hours, right? AWS services also work together like a building block. Means you can use those services in a combination. Like whatever architecture or whatever application you are designing, that is not using any single service. You can create any architecture. There is a list of services or we can say bunch of services we are using to create a simple application or we can say simple architecture. For that we can use the list of services, and we for that we require any of the service communicate with any other. And there are also services available who can from which you can create this kind of communication, right? For example, there is a role IAM role. Using IAM role any two services can communicate with each other. Like all the services are different, right? If you don't allow any service to communicate with other, then they will then by default it is not available. Like EC2 instance can communicate with S3 storage, never. You have to define the policy and you have to assign the permissions to each of them, right, to communicate with that. And it is very easy to available. So AWS all the services work together like a building block. Okay. So the next is this the main categories of AWS services. Okay, so first is the analytics. These are the major category, and in each of those there are list of services. Like in analytics we have a Kinesis, we have a service called Redshift, and there is a service called Glue. Means Glue is these all kind of services which provides different kinds of work. Like using Glue you can run your ETL job, right? Extract, transform, and load. The second is the application integration. Application integration, as the name suggests, it is used to integrate your application, right? So integrate that means right. If I want something like if anything change on my server, then I it will notify to me. Is using SNS. Is it is SNS is a one service called simple notification service, which is a part of application integration. Using this service, you get to know about yes something is changed your at your server or all that. Like the third one is the AR/VR. It is augmented reality and virtual reality. It is also available. Sumerian is one service from which you can uh, create your augmented reality and virtual reality and all that. I have never used this service much, but I have a little bit of idea of it. The fourth one is the blockchain. Blockchain is also available from 2019, and there is the one separate database called Query Legenda database for blockchain services. The next one is the business application. A business application in the business application we have a service. There is a service called Chime. It is the same as a Zoom or Meet. We can say to video conferencing call. There is a service on AWS. It's called Chime. There is another service called Alexa for business, right? Alexa is a device through which you can communicate and do your task. If you create your own skill and you have to sell it, then using Alexa for business service, you can do that. The next is the compute. The compute is a core service of AWS, and the major service of compute is EC2. The next is the Elastic Beanstalk, which is we can say it is the same like compute, but it is a platform as a service. The third service which provides computation is AWS Lambda, which is completely work as a serverless. There is a services called containerized services like ECS and EKS. It is Elastic Containerized Services on which you can run your Docker container, and EKS means Elastic Kubernetes Services, on which you run your Kubernetes cluster and maintain it, right? So the next services are cost management. The cost management means you can manage and maintain, or you can create your budget, or you can put billing alarm. You can even see the forecasted cost, and you can see which services cost me how much. You can see the detailed report of all that. Like right now, if I have a 10 server running on my machine and 3 database, then uh, I can see that which server cost me more. Like if every server have a different configuration, then I can check the report on the cost management. There is a service in a cost management called Cost Explorer, in which even I can see that uh, like if on this September month, if I get a billing of $100, then how much shall I have to pay in the next 3 months? Means it's forecast you that how much costing is there if you run the same kind of workload on in the future as well. Then okay, the next is the customer engagement. Customer engagement means that they provide you a support and all that, so you can communicate with them with the AWS as well. Right. The next one is the database. Database I already covered in a previous slide. There is a service called IRDS, then DynamoDB, then Redshift, then Neptune. All the services which provides you database as a service. You don't have to pay underlying operating system or server. You just have to run your database on those server, right? Everything means patching of operating system and all that will be managed by AWS. The next is the developer tool. The developer tool means it's a concept like a CI/CD, right? CI/CD, if you have heard a term, continuous integration and continuous pipeline. Most of time nowadays, these are useful in a uh, DevOps and all that. Means it is useful for automation. For a DevOps tool, there is a service called Code Commit, which is working similar as a GitHub. Then there is another service called code pipeline, in which you can just push your code in a code commit, automatically deploy it to any of the service. Like if you want to deploy your code on EC2, if you want to deploy your code in a ECS cluster or ECS container, or if you want to deploy code on a EBS platform environment, then you can create a pipeline. The code pipeline automatically deploy your code whenever you change and push your code in a good code commit, right? Okay, the next one is the end user computing. End user computing, this kind of app is means amplify, and we can say mobile hub, from where you can create and maintain your Android application. uh, all those services are the part of end user computing. The next is the game technology. You can create and run the game using game tech. There is a services also available for game tech. The next is the IoT. In IoT, there is a service called IoT Core, IoT Greengrass, which have a different kinds of use. When you want to connect your Raspberry Pi or Arduino with AWS services, you can connect using IoT Core and IoT Greengrass service. The next is the machine learning. For machine learning, there is a already created machine learning model over there. You can just simple use this. You can load your database and use that. Like there is a one service called recognition. You can use this to recognize face. Like nowadays it is a very useful. Everyone and we heard the term like face recognition and all that. You can do it very easily on AWS using Amazon recognition service. You just have to upload your photo, and you can recognize like there is a specs you have wear or not, or it is a female or male, or many more. Means you can also fetch the words, or we can say from photographs. Like if there is something written on the photograph, then you want to fetch those words, then you can using Amazon recognition service you can do does that as well. The next one is the management and governance. It is more like a security compliance and compliance and uh, security services management. Like IAM is a part of these services. You can manage the users, groups, or policy. And other services for security is KMS, means key management, storage, and all that are a part of management and government. Then there is a media services, elemental media services. To convert your video or to convert video in any other format, like from MP4 you want to convert it in HLS or any other format, then using media services you can do that. Okay, the next one is the migration and transfer. Migration and transfer means you want to migrate your database from on-premises to AWS. Then using database migration service you can do it very easily. The next, then if you want to migrate your whole server, then using server migration service, you can migrate your whole server to the AWS, right? There are list of services available to migrate your on-premises workload to the cloud using migration and transfer service. If you have a large number of data, or we can say huge data, about we can say 20 terabyte or 30 terabyte, so using Snowball is one service. Using that, you can transfer your data. Okay. The next is the mobile. Mobile is as same as end user computing, but there are different service called mobile hub, or I forgot the name. You can manage the mobile application using those services. Okay. The next one is the network and content delivery. Okay. So networking and content delivery means that VPC, and we can say CloudFront. CloudFront is a service to improve the performance, like to cache all your things, to cache your data. You can use content delivery or CDN service, which is cache your data at the edge location. So if you want to increase the performance of your website, then you can use those services. The next one is the robotics. If you want to maintain a robot, then you can use robotic services, then satellite, then security, identity and compliance, and the next one is the storage. You can see there are a list of services, more than 100 of services. But the more services and core, we can say core services of AWS are compute, storage, networking, and database. Most of the organization nowadays use those services most. But and yes, a developer tool means for automation and on DevOps guys, they are using CI/CD pipeline and all that. So this is the overview of all the services which are available at AWS, right? Okay. The next way, yes, we have till now we have seen what is AWS, how which of the services are provided by AWS. But the question is, how can we interact with AWS? Right? There are three ways to interact with AWS, and those ways are using AWS Management Console. It is the same as a website, right? You have to return like AWS console on Google, and you get aws.amazon.com one link, and you can just log in and sign in, and you get Amazon Management Console. You can use any of the service from that management console. The another way to working with Amazon service is the CLI. You can use AWS CLI to uh, communicate with AWS services. Like for that, you have to create access key and secret access key, and you have to download AWS CLI software from internet, and you can use those services using command. Right? If I want to create EC2 instance, but I don't have any kind of access of AWS console, then using AWS CLI, I can do the same thing. But for that, you can access the services by scripts or command. Right? Okay. The next way of interacting with AWS is the software development kit or SDKs. Access services directly from your code. Like if I have a Java code and I want to access some of the storage file which is stored at the S3, then I can use Java SDK for AWS to interact from my Java code with S3 service. And at that time, I can use software development kit. There is a software development kit available for Java, Python, Node.js, .NET. I think these 4 or 5 languages, programming language supports software development kit. So if you want to communicate with any of that services, like in a Python, there is one library called Boto3. Using that library, you can communicate with any of the AWS services, right? So using this software development kit, you can also communicate with AWS services. So this is the three ways from which you can communicate with AWS services. Okay. So next is the AWS Shared Responsibility Model. So what is it? What is the meaning of shared responsibility model? Is that the main thing which is we can say as a AWS Shared Responsibility Model is that in any of the cloud provider, there are some responsibilities are AWS or any of the cloud provider, and some of them responsibility are the customers. Like, right here is the image. You can see that on the left hand side there is a two part. One is the customer and another one is the AWS. The orange part is the AWS, and you can see that there is a written responsibility for security of the cloud. So any of the cloud provider is only responsible for the security of their cloud, right? They have to they have a responsible for managing their services like compute, storage, database, and networking. And also, they are responsible for their hardware and all the global infrastructure. They are never responsible for your data, your encryption, anything, right? You can see it. On the bottom, they have written region, availability zone, edge location. This is called AWS Global Infrastructure. So it is responsibility of them. Like if any disaster occurs and if any availability zone goes down, then to uh, make it all again available, it is responsibility of AWS. It is not your responsibility, right? If data center goes down or any networking issue is there, any service issue is there, then it is responsibility of the AWS. It is not your responsibility. But if you have your store your data on S3, then it is your responsibility to which kind of security or which kind of encryption method you want. Right? You cannot say Amazon to secure your data. If you want to encrypt your data, then you have to put all those kind of policies over there. So encrypt your data. It is completely you are responsible for. So we can say that customer is the responsible for security in the cloud. Please keep those things in mind. Customer is responsible for security in the cloud, and AWS or cloud provider is responsible for security of the cloud, right? You also responsible for your platform, your application, and identity and access management. Like in organization, how much users wants which services and who have which kind of access is all the defined by you. It is never AWS is will never responsible for that. Then the yeah, as I mentioned, you are responsible for your encryption, like client side data encryption or data integrity or authentication, or server side encryption, or you have to provide network traffic protection, firewall configuration, network. All things will be your responsibility, right? So you can see it is a complete understanding, like for which AWS is responsible and for which you are responsible, right? Okay. So the next thing is AWS Well Architect Framework. There are mainly five pillars. We can say these are five well architect framework pillars. The all those pillars is first one is the operational excellence. The next second one is the security. Third one is reliability. Fourth one is the performance efficiency, and fifth one is the cost optimization. Operational excellence means we can say everything is working as it is like you can say run, manage, and monitor the production workload to deliver business value and continuously improve on supporting process and events. Means everything is working fine or not. We can check it using operational excellence. Right. Second one is the security. Means protecting information, systems, assets along from outside world with a risk assessment, unplanned failures, and mitigate threats. You can use the security services to check which of your services are not secure, or we can say which of the services are non-compliant. Using security services, you can check all those things. Like using like there is a one service called Trusted Advisor. In that you can check which services are reach at the service limit, or using config service you can check what which of the resources are non-compliant. You can check all those things from the security service. The next thing is the reliability. Means how much your architecture is reliable. Reliability it means reliability means if any disaster or failure occurs, then after how much time your infrastructure or architecture will be available. Auto recover workload from the infrastructure is called reliable. Means or we can say fault tolerant. Means if the disaster occurs, then your infrastructure is able to to deal with this kind of disaster. Like for that they support some services called multi-AC, right? They always prefer to put your database server or web server in a two availability zone. So if one goes down, then another will be working, right? So there is one pillar for reliability, which is, and there are some services which provides you uh, same kind of concept to create your architecture reliable. The next thing is the performance efficiency. Performance efficiency means use computing resources and all that for performance. And cost optimization, as I cover, you can uh, use those kind of services which may cost you less, right? It's called cost optimization. The next is the Amazon certification. Why it is important, and as I see well architect framework and all these things came into AWS certification. So the pathway for the Amazon certification is that you can see there are four types of certification. One is the foundational, second one is the associate, third one is the professional and specialty. It is not like that you have to compulsory follow this path. Like first you have to do foundational, then associate, then professional and specialty. You can do any certification at any time. But AWS will recommend to go by path. Like if you first you clear the practitioner certification, then go with the associate level, then go with the professional level, then specialty. Because the difficulty level will increase as you increase the level. The foundational level is very easy. There is not any kind of scenario questions available in a cloud practitioner. But as you go into associate level, there is some kind of scenario questions are there. If you are going for the professional, some more or scenario level questions will that. And specialty, it is completely for the specific domain, right? Okay. So you can, I will give you how to prepare for that. This is the table which says Amazon certification cost. As you say, foundational will cost you $100. Associate level cost is $150. Professional has a $300, and specialty has also $300, right? And duration is 90 minutes, 130 minutes, 180 minutes, 170 minutes, and 180 minutes respectively for all those. You can get all this information from AWS certification websites as well. I have taken all the information from that only. Okay. The next one is how to prepare for the certification. So the preparation is you can take classroom or instructor led training. Training means there is one website aws.training. You can get training from that. It will give you a great help, or we can say there are uh, the instructor of AWS give you the lab access and all that, so you can prepare for the exam. The other video training are available as there is a online a cloud group videos are available on Udemy. There are a lot of courses available you can learn for AWS certification, and Linux Academy is also one of the platform for where from where you can learn about this certification. Labs and hands-on. Okay, there is a free tier account. Like if you don't have AWS account, then you can create free tier account. You can perform the labs on a quick lab to get get an idea about how hands-on. And first one means 12 months, AWS will give you free access, but not all the service. Please keep those things in mind. They will provide you free training, but not all the services. There are limitations in free tier as well. And other resources are you can find the exam blueprint on AWS sites. You have to read all those. Then you can see the white papers, which are most important for all the services. Then reinvent videos are also available. And read the AWS Amazon FAQ means there are FAQs for all the services. Please read it before giving the AWS certification exam. These are very important for your certification, right? I highly recommend to all the students, please follow this path and please do the certification. It will really very helpful to all of you, right? Anything else you want from my side? Okay. This is
Yes,
all
guys.
about
Guys, you have any kind of questions? So please send the my number. So I ask the ma'am. Okay.
don't worry, I will provide my email address over here. So if you have any doubt, then please email me. I will definitely help you with that. And or else, if you don't email me, then please message me on a LinkedIn. I will give you reply as time, right?
Yes, ma'am.
This
It's
is my
really
this is my LinkedIn profile and this is my email address. If anyone have a doubt or anything, then please email me or message me on a LinkedIn. I will definitely help you with that.
yeah, really, ma'am. It's very informative lecture today, and I really thankful on behalf of the Parul University. And it's my student. I think they are got lots of information from your side. So really, thank you. This is the one of the good lecture today. So, ma'am, it's and this is very highly means informative information you have to give in this lecture. So really thankful to you, ma'am. And now. Uh,
Thank you, sir. Actually, AWS is a very vast. You can never complete it within an hour, but I will try as much as possible, and I will cover all those main points which are helpful helpful in industry as well. So actually, if you want to learn AWS, then it is must required to play with that. Means get an hands-on experience and all that. So you play with that, and you get more idea about how it exactly work, right?
Yes, guys. Anyone have any kind doubt? So please, if you want any query, so send in my here in WhatsApp number, so I can ask the ma'am. Else you directly ma'am given to the email ID, so you can ask any kind of query to direct ma'am. Okay.
Okay, sir. Anything else from my side, sir?
Okay. No, ma'am. Now it's really thank you. Your session is very nice, ma'am.
Okay. Thank you so much, sir.
Okay.
Sir. Okay.
Thank you again to you give